This is 2.4. We're going to be talking about functions, and parent functions is really the lesson that we're going to be talking about. This leads us to translating and shifting functions in the next lesson, but we have to know what the parent functions are. So you've seen every one of these functions that I have here, and you've probably seen several other functions at this point, but these are very common functions. Every one of these 8 functions, you've seen them multiple times. I want you to know how to do these functions without a calculator. I want you to know what they look like, their behavior. I want you to become familiar with them. So, one, if you have a good memory, that's all you really have to do is just look at it and study this, and you're familiar with it. If you're not sure, like there's no way I can memorize those 8 functions. Well, one of the ways that you can easily do it, like chart. So again, it's the more familiar that you're with the functions, it will help. So this is our basic y equals x. And so any x value that I have, the y will also equal that. So 1, 1, 2, 2, -3, -3, -5, -5. So anything that x equals, y equals. And as soon as you start graphing that, you're going to notice that 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and -1, -1. So it's basically a diagonal line. So making an XY chart can always help you graph it. But it's easier, again, if you remember, the diagonal y equals x is the diagonal line. Here, y equals x squared, you've seen this problem multiple times. It's just a parabola that's going up. But again, if you start making up your numbers here, 0 and 0 squared is 0, 1, and then 1 squared is 1, 2, then 2 squared is 4, 3, 9. And the cool thing about parabolas, remember they're symmetrical. So once you know 0, 0, 1, 1, 2, 4, 3, 9, then you can just reflect them on the other side. X cubed. Well, again, you should know this is a positive x cubed. If you don't know what the positive x cubed, you can always make an xy chart. And I would always start with 0, so 0, then 0. And then if I plug 1 in, 1 cubed is 1, so 1, 1. Now watch what happens when I start plugging in bigger numbers. So when I plug in 2, 2 cubed is 2 times 2 times 2, which is 8. Even 3 cubed is going to give us 27. That's kind of a big number to graph. So let's just graph 2, 8. Now, what happens if I plug in -1? Well, -1 cubed means -1 times -1 times -1, that's -1. And then at -2, I'm going to get -8. So within literally about 30 seconds to a minute, you have this graph. Okay, so that's what x cubed, positive x cubed, looks like. By the way, if there was a negative outside, so negative x cubed, again, you can make an XY chart, but it's going to basically opposite direction. It's going to be like that. So just be familiar. Again, make familiarity is the best thing. To know what x cubed is, and then negative x cubed. Even back on this one right here, so what if I gave you y equals -x squared? Well, again, if you just flip it downward, so again, the negative on the outside literally flips it or reflects it to the bottom. Flips it, or in this case, reflects it across the y-axis and x-axis, so you just literally flip them. All right, so y equals absolute value of x. So the cool thing about this, again, if you know it, you know what it looks like. But any number I plug in, I'm always going to end up with a positive answer. Even if -1, but the absolute value of -1 is 1. -2, the absolute value of -2 is 2. And -3, and the absolute value of -3 is 3. So it's going to look like a V. So again, it's easy to memorize this, but it's also a lot easier if you just, it's easier to memorize it, but then if you need to make an XY chart, you can easily make an XY chart. And then 1 over x, again, making the XY chart, if you're not familiar with this. Now this one This one's an interesting graph. So if I plug in, you remember here x cannot be 0. So I can't put 0 in the xy chart. But if I put 1 in, so 1 divided by 1 is just 1. So I know I have 1, 1. If I plug 2 in, so that's 1 divided by 2. If I plug 3 in, that's 1 divided by 3. Plug 4 in, that's 1 divided by 4. And what happens if I plug in just a half? So 1 divided by 1/2, that's 2. 1/3. So 1 divided by 1/3 is 3. So if I start graphing this, notice what's going to happen. This is going to get very, very close, but never actually hit. Remember, x equals 0 cannot happen. You cannot have x equals 0. And so here, this is going to get very, 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 very tiny. And it's going to look like that. And if I made another xy chart up and started plugging in like -1, well, 1 divided by -1 is -1. Plug in -2. Well, that'd be -1/2. And -3, that'd be -1/3. So notice this is going to do the exact same thing. It's never ever going to touch this line, and it's never ever going to touch this line. So it gets very, very close to those, but it doesn't actually hit them. And by the way, that's going to help you because later on we're going to add things to this. Like later on, I'm going to ask you to graph like 1 over x plus 2 minus 3, and you should know what this number does and what this number does to the graph. And it's going to actually help you graph really quick without a calculator. All right, and then we've talked about piecewise functions before, so I just want to remind you about a piecewise function. So here, if I had, if x is less than or equal to 1, so again, imagine an xy chart that all of the x's are less than or equal to 1. So 1, 0, -1, -2, -3, and that's what that's referring to. And then you're going to plug those numbers in, and they'll be able to get to your answers. So if I plug 1 in, like I'm literally plugging it in right here. So 1 times 1/2 is 1/2, plus 3 is 3.5. Plug 0 in, 0 times 1/2 plus 3, and I'm going to get 3. Plug -1 in, I'm going to get 2.5. Plug -2 in, I'm going to get 2. Plug -3 in, 4, -5, -6. Got to graph it. But notice it's also y equals mx plus b. Okay? So if you started at 0, 3, and if you did down up 1 over 2, just up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. But be careful because the smallest number, don't just connect them. The smallest number you can have, because it's less than or equal to 1, so 1 is the smallest number you can have to be able to do that. And we got 3.5. This line, it's actually not a line, it's a ray. It can only be numbers that are, oops, I went the wrong direction. I went greater than 1. It's less than or equal to 1. So let me back it up. It's a good thing I'm double checking. So even if I make a mistake here, it's a good thing I'm double checking. So normally we start at 0, 3. And then I'm going to go up 1 over 2, up 1 over 2. So normally I go up 1 over 2 to the right, up 1 over 2. Connect the dots. But here, only less than or equal to 1 to be able to do that. So literally at 1, it's 3.5. And I can't have anything to the right of that, only less than. So again, if you want to do slope, instead of going up 1 over 2 to the right, I'm going to go down 1. And then 2 to the left, down 1 and 2. So it's going to be a line like this. And again, this is your starting spot right there. That's your starting spot because it's less than or equal to 1. X equals 1. All right, so if we look at the second one, negative x plus 4, and again, x is greater than 1. So if I plug 1 in, I'm going to get 3. Now, at 1, 3, you're going to have an open circle at 1, 3. It cannot be equal to it. And then from there, you're just going to go down 1, over 1, down 1, over 1, down 1, over 1. So they're both lines in this case. And notice you have a closed circle and an open circle at 2 different locations. That's how you graph a piecewise function.